All right, in number 1, I want to multiply by a common denominator, which in this case is going to be x plus 3 over x plus 3. And then I want to distribute that in with each term. Okay, so what's going to happen then is I get, up top, I get x times x plus 3 plus, well, the x plus 3s are going to divide out for that term, so I just get 1 up there. And in the denominator, I get x times x plus 3, and this time it's just minus 1. And again, I cannot divide out with what I've got, so I need to distribute. So x squared plus 3x plus 1 over x squared plus 3x minus 1. That actually is not factorable, so at this point we are 100% done as far as that one goes. All right, in the second equation, I want to bring the 1 over. So I get 2x square root of 2x plus 1 equals x minus 1. Then I want to square both sides, which gives me 2x plus 1 equals x squared minus 2x plus 1. And then I want to bring all the terms to the same side. So that's going to equal 0. So x squared minus 4x, 1's cancel out. I can easily factor out an x, so let me do that. So x times x minus 4, which gives me x is 0 and 4. So before I get too excited about that, let me come up here and let's check the math. Well, okay, so the 0, I can see there's already a problem. So we put a 0 in this. Let's see, I get 2 times 0 plus 0 plus 1 is still going to be 1, so 0 is not going to check. And if I do the 4, I get 2 times 4 is 8 plus 1 is 9, square root of 9 is 3, 3 plus 1, okay, that actually does equal 4, so a little x through the 0 there, but anyway, so that one, that's how you do that. At number 3, we're asked to find the difference quotient. So there's 2 different equations we're going to do this on. So I want f of x plus h. So I want, for that first one, would be x plus h squared plus 3 times x plus h minus 1 minus the original function, x squared plus 3x minus 1 all over h. Okay. So then I'm going to FOIL it, distribute, combine like terms, do what I can up top. So I get x squared plus 2hx plus h squared. Then distribute the 3 in, so plus 3x plus 3h minus 1 minus x squared minus 3x plus 1 all over h. And if I look very carefully, I should see a couple of these things are going to cancel out. So let me go find those. Okay. And then I want to write down what's didn't divide out. So 2hx plus h squared plus 3h all over h. And I can see that I can factor, well actually I can divide each of those 3 terms by h. So I get 2x plus h plus 3. That's my final one there. Okay, in g of x, so I've got negative 1 over x plus h minus a negative 1 over x all over h. Okay, so I'm going to go ahead and find a common denominator up in the numerator first. So that's a negative 1 times x, subtract a negative 1 times x plus h all over x plus h times x. And then we've got that fraction rule that says if you're dividing by something, you multiply by its reciprocal, and all that's going to do is put the h in the denominator for us. So h times x plus h times x. And then I can just distribute that in there. So I get the negative x plus x plus h. And I notice that the x's cancel out. and I'm left with h over h times x plus h times x. And notice that the h's divide out. And so I am left with 1 over x plus h times x. And so that's our difference quotient for that one. And number 4, I just want to caution you, even though it looks like they're very similar questions, the fact that absolute value shows up in 1 changes drastically how you go about solving it. And the fact that the other one is squared also changes that. So they're definitely going to look like two different problems when we're done. So on this one, I want to bring over the 6. X squared plus x minus 6 is greater than 0. I want to factor it. So that's x and x, 3 and 2. I want the plus there and that, the 2 to be minus. And then this is where I want to solve for x. So I get 2 and negative 3. And then I want to set up a number line where I'm going to pick test values in between. So something less than negative 3 like negative 4, something between negative 3 and 2 which is 0, something bigger than 2 which is 3. And then I want to go back into that factored form. So if I do, so I'll kind of write out this first one, but it's the idea behind it. A lot of this I'll just do mentally. So negative 4 minus 2 times negative 4 plus 3. Okay, so I get a negative times a negative, which ends up giving me a positive result. Then if I put 0 in there, so think 0 minus 2 and 0 plus 3, I get a negative and a positive, which overall gives me negative. And then if I put a 3 in there for both, I get a positive positive, which gives me a positive result. My inequality symbol wants me to look at the greater thans, which is the positives. So I see the positive numbers all the way up to negative 3, so negative infinity up to negative 3 union 2 out to infinity. Now when we learned this, we talked about brackets versus parentheses, so I would definitely go back and review that case and make sure you're clear on that. The other one is the absolute value one. And this is another thing that we talked about where less thans and greater thans, and if it's positive or negative on the right, makes a difference. So this is just one of the 4 cases that we've covered in class, so you do want to go back and kind of review what are the other rules if the symbol changes on us. In the greater than case, I'm going to split this up as a OR statement, so 5x plus 4 is less than negative 8, so it's like I multiplied by negative 1 on one side, but the absolute value goes away. And 5x plus 4 is, I'm sorry, I didn't switch the inequality there. It's greater than or equal to negative 8. And then 5x plus 4 is less than 8. And then I want to go ahead and solve the 2 equations independent of each other. So subtract off the 4, so I get 5x greater than negative 12. And then divide by 5. So x is greater than negative 12 fifths. Over on the other one, subtract 4, so I get 5x is less than 4. And divide, so that gives me x is less than 4 fifths. Okay, sorry, it took me a second. My symbols are the wrong direction. That's what happens when I have to do too many review problems in one day. Okay. With the negative, it does switch, so it should say less than. The positive stays the same. Like a sound, okay. Anyways, so in interval notation, it should be negative infinity up till negative 12 fifths union 4 fifths up to infinity. And there we go. All right, at number 5, we got to remind ourselves what a recursive pattern is. Typically, a recursive pattern means that the next number depends on the position in the pattern. So in this case, when they give us the first number being 1, And then they say that the nth number, so in this case the second number, would be, I'm just going to fill in these positions here, minus 2. So we're just put 2's in for the n's. Well, that simplifies down to the first number minus 2. Okay, so what that means is I want to subtract 2 from 1. So 1 minus 2 is negative 1. Okay. So what's going to happen next is every number after this I'm just going to subtract 2 from. So negative 1 minus 2 is negative 3. Negative 3 minus 2 is negative 5. So you need one more. Negative 5 minus 2 is negative 7. Okay, so those are the first 5 numbers of that pattern. Find the indicated term of the arithmetic sequence given the following information. So I have to remember the nth term is the first term times the common difference times n minus 1. So then I'm just going to fill that in. So the 15th term in this pattern would be 5 plus 3 times 15 minus 1. So 5 plus 3 times 14. And that's a great calculator. Well, 33 times 14 is not too bad, but anyways, I should get 47 for the 15th term. Okay, number 7, they're asked about an infinite geometric series. So the pattern here is if R is divergent. Divergent means greater than or equal to 1. I guess I should say the absolute value of R. Then the sum is infinity. In other words, if I keep adding together an infinite set of numbers where they keep getting bigger and bigger and bigger, then I would expect that the sum of an infinite set of numbers that are getting larger and larger to be infinity. If, on the other hand, I have what's called a convergent pattern, and that's where the absolute value of R is less than or equal to, just less than 1, can equal 1, then it's 1 over 1 minus, the first number over 1 minus R. Okay, so in that first pattern, first thing to do is figure out what R is, and the easiest way to do that is to take the second one divided by the first one. So if I take negative 1 divided by the one before it, that gives me R. Well, that means it's getting smaller, because it's clearly the absolute value is less than 1. So it's 3 over 1 minus R. So that's 3 over 1 plus 1/3. So 3 over 4/3, which gives me 9/4. So if I add up that whole sequence, that's eventually going to get right around 9/4. Okay, next pattern. So take the latter divided by the previous, so the second divided by the first. So that's 3/4 times 2 over 1. That divides out, and I'm left with 3/2. Okay, so that tells me that I've got a divergent pattern here. So if I add up an infinite number of things that are getting bigger and bigger, I actually would end up getting infinity. Okay, number 8, I want to remember how to find 3 good points using our parent functions and mapping properties. So I'm going to just copy this. Actually, I can do it to the side here. Let's just do that. So our parent graph for the square root of x, and it's got ordered pairs of 0, 0, 1, 1, and 4, 2. That's just a memorized fact, actually from college algebra, hopefully, and back when we did it in this class as well. The mapping is, if I look at any ordered pair from the parent, well, what's going to change it? Well, the x's, if I look inside, I see x plus 1, so it's actually opposite of that. We're going to subtract 1 from the x's, and the nice part is, if I actually rewrite the function with y, that actually tells me what the y values are doing. And so all I have to do is follow that rule with all these ordered pairs. So if I subtract 1 from all the x's, 0 minus 1 is negative 1, 1 minus 1 is 0, 4 minus 1 is 3. And then the y values, I want negative y minus 3. So negative 0 minus 3 is negative 3. Let's see, negative 1 minus 3 is negative 4. And let's see, negative 2 minus 3 is negative 5. Okay, so those are the points that I'm going to plot. So negative 1, negative 3, 1, 2, 3 right there. Actually, a little bit lower. 0, 4 is 1, 2, 3, 4 right there. And 3, 5. 1, 2, 3, 1, 2, 3, 4, 5 slightly off the screen. And then connect that, and there's my graph. In the other parent, I'll scroll over so I can see this all. Okay, so our parent graph is x cubed. And so the critical points that define it were negative 1, 0, 0, and 1, 1. And so my mapping, let's see, the x-axis is x plus 2, so that means I'm going to subtract 2 from all the x's and do a little y, replace the y. So that's just y minus 4. Okay. So going to all of my ordered pairs. So the x's, I'm going to subtract 2. So negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 1 minus 2 is negative 1. And then all the y values, I'm going to subtract 4 from it. So we get negative 5, negative 4, and negative 3. And then plot those points. So let's see, can I get the negative 3, negative 5 on there? Let's see. 1, 2, 3, negative 3, 1, 2, 3, 4. So right down there. Negative 2, 1, 2, negative 4, 1, 2, 3, 4, right there. And negative 1, negative 3, 1, 1, 2, 3, right there. Okay. So then I have to understand enough about the pattern that it's supposed to look like a curve. And so that's what our graph looks like.